Hey everyone, welcome back to the channel. Today, we're diving deep into the fascinating world of hovercraft. Ever wondered how these futuristic-looking vehicles manage to glide smoothly over land and water? Well, you're in the right place because we're about to break it all down for you in this epic journey. So, buckle up and let's hover into it. First things first, what exactly is a hovercraft? Simply put, it's a type of vehicle that can travel over various surfaces, including land, water, mud, ice, and even swamps, with remarkable ease. The magic behind its movement lies in a combination of physics, engineering, and a dash of sci-fi flair. Let's start with the basics: lift and propulsion. Every hovercraft has a cushion of air underneath it that provides lift, allowing it to hover above the surface. This air cushion is created by a large fan or fans, typically located at the rear of the craft. These fans draw in air from the atmosphere and force it downwards, creating pressure that lifts the craft off the ground. Now, you might be wondering, what about propulsion? How does a hovercraft move forward? Great question. Hovercraft use thrust to move forward, similar to how a boat uses propulsion from its engine. The thrust is generated by another set of fans, known as propulsion fans, which are usually located at the rear or on the sides of the craft. Picture this as the propulsion fans push air backwards. Newton's third law of motion kicks in. For every action, there's an equal and opposite reaction, right? So, when the fans expel air backwards, the hovercraft moves forward. It's like a high-tech air-powered push. But wait, there's more to the hovercraft's propulsion system. Many modern hovercraft also incorporate directional control systems, such as rudders or movable vents, to steer and navigate. These systems allow the pilot to adjust the airflow and change direction, making hovercraft surprisingly agile despite their size. Now, let's talk about the skirt. No, not the fashion kind. In hovercraft terminology, the skirt is a crucial component that helps contain the air cushion and improve efficiency. There are different types of skirts, including segmented skirts, bag skirts, and finger skirts, each with its own advantages in terms of stability, lift, and maneuverability. The skirt works by trapping the air underneath the hovercraft, preventing it from escaping too quickly. This trapped air creates a continuous cushion that supports the craft's weight and reduces friction with the surface below. Think of it as a cushioned barrier that keeps the hovercraft floating smoothly. Speaking of surfaces, hovercraft are incredibly versatile when it comes to where they can operate. Unlike traditional vehicles that are limited to roads or waterways, hovercraft can glide over almost any terrain, from grassy fields to icy lakes. This adaptability makes them invaluable for various applications, including search and rescue missions, military operations, and even recreational use. Now, let's delve into the nitty-gritty of hovercraft design. There are several key elements that engineers consider when designing a hovercraft. The size and weight of a hovercraft play a crucial role in determining its lift requirements and overall performance. Larger hovercraft typically require more powerful engines and fans to maintain sufficient lift and propulsion. Hovercraft can be powered by a variety of engines, including gasoline, diesel, electric, and even hybrid systems. The choice of power system depends on factors such as fuel efficiency, environmental impact, and operational requirements. As mentioned earlier, the skirt design influences the hovercraft's stability, lift, and maneuverability. Engineers often experiment with different skirt configurations to optimize performance for specific applications. Modern hovercraft are equipped with advanced control systems that allow pilots to adjust speed, direction, and altitude with precision. These systems may include electronic controls, hydraulic systems, and manual overrides for safety. Now, let's address a common misconception about hovercraft: the myth of frictionless travel. While hovercraft do minimize friction with the ground or water, they are not entirely frictionless. Factors such as air pressure, surface conditions, and wind speed can affect the hovercraft's performance and efficiency. Alright, let's take a moment to appreciate the history of hovercraft. The concept of a vehicle that hovers above the ground dates back centuries, with early prototypes and designs appearing in various cultures. However, It wasn't until the 20th century that hovercraft, as we know them today, began to take shape. One of the pioneers in hovercraft development was Sir Christopher Cockerell, a British engineer who patented the first practical hovercraft design in 1955. His invention, known as the Saunders-Roe Nautical One, made its maiden voyage in 1959 and marked the beginning of a new era in transportation technology. Since then, hovercraft have evolved significantly with advancements in materials, propulsion systems, and design concepts. Today, we have hovercraft that can carry passengers, cargo, and even vehicles across challenging terrains, opening up new possibilities for transportation and exploration. Some modern hovercraft use electric or hybrid propulsion systems to reduce pollution and noise. Hovercraft are designed to operate in a wide range of weather conditions, including rain, snow, ice, and high winds. However, extreme weather may affect performance and safety, so pilots must exercise caution and follow proper procedures. How fast can hovercraft travel? The speed of a hovercraft depends on factors such as engine power, skirt design, and surface conditions. On average, hovercraft can travel at speeds ranging from 35 to 70 miles per hour, with some specialized models capable of exceeding 115 miles per hour. Hovercraft can travel over land, water, ice, and other surfaces, making them ideal for diverse environments. Thanks for joining me on this hovercraft adventure. Don't forget to like, share, and subscribe for more epic explorations into the world of science, technology, and everything in between. Until next time, keep soaring or hovering to new heights.